Hi, this is another question about p-values. This says number 5. This is the homework examples I usually do in class. I think it's number 4 actually in the homework. The numbers might be a little bit different. But it's another one where they ask you to find p-values. So again, find the p-value. For 8.1, we're going to use this chart. We're going to use normal CDF. And 8.2 and after that, you can use your calculator, and your calculator will actually spit out the p-value for you. Okay, so just to start off with here, let's go through these first 3 steps so we can kind of tell whether we have a left tail, right tail, two-tail test. So the first thing is we want to identify the claim. That's step 1, and put that in symbolic form. That's already given to us in symbolic form. So again, I'm just following these first 3 steps here. Step 2 is you write down what must be true and that's false. So the opposite of not equal to is equal to. And then step 3, you find the null and the alternative. The alternative is whichever one of these does not have the equal sign, so that'd be this one. And the alternative is always, the null is always equal to. Okay, so right away we know what kind of test we have. I had you guys write this down, and it explains in a different video. We know it's a two-tailed test. Oops, I can't spell. So I'm going to go ahead and draw a stair normal with 2 tails on it. And the p-value is basically those 2 areas add together, and these should be the same. These should be symmetric, so the areas should be about the same. They don't look like it with my picture, but they should be the same area. So I can just take one of them times 2. So here's my test statistic, 2.18. We go over here. Okay, so the way I find the p-value is I want to take this area times 2, or take this area plus this area, which is, if this was negative 2.18. Okay, so just to kind of show you how to do that here, what type of test do we have? It's a two-tailed test. We go down here, it's two-tailed. Is the test statistic to the right or left? The test statistic is positive 2.18, so it's to the right. So the p-value, I can zoom in here, is twice this area to the right of 2.18, or again, you could take this and then plus negative 2.18. So I want to basically find this area using normal CDF and then multiplying it by 2. So what I'm going to do is take this area times 2. So the way I find this area is I put in normal CDF my low, my high is infinity, so I just put a bunch of 9s. And then 0, 1. Again, this comes from chapter 6. And you end up with 0.0146. Now, we do want to multiply that by 2 when it's 2 tails. So if I take that times 2, we do get this p-value. It might be off a little bit, but you get about that value. I think it's 0.292. And you only multiply by 2 if it's 2-tailed. In this section, the other sections of programs just automatically do it for you. Okay, so we found it's a two-tailed test. We found the p-value. Oops, there we go. Now we're going to come with the conclusion. So if you have to pause this, go right ahead. Okay, to come up with the conclusion, we compare the p-value with alpha. P-value is smaller, I reject the null. The p-value is greater, I fail to reject. Okay, so let's look at the p-value. Here's my p-value. I'm just going to write up here and write alpha. My alpha is 0.01. In this case, it's greater. So whenever it's greater, you should fail to reject the null. Okay, so it's going to be one of those two. Now, decide which one it is. Whenever you reject the null, you're going to say the alternative is true. When you don't reject the null, you're going to say, I can't prove this to be true. So basically, you're going to say, there's not enough evidence to support this claim, so you can't prove this to be true. So you should pick C for that one. Okay, so I'll stop there for this one.